My name is Christopher Deloglos. I'm product manager at Weidmueller for UOS, which is our operating system for industrial IoT and automation. I'm going to talk a little bit today about control architectures and where we think modern control architectures are going and how CODESYS is powerful in enabling that. And so first, I'd like to lay out some principles. These are not absolute, and I love to have conversation about these. So if you have ideas, if you agree, if you disagree, my contact info will be at the end of the presentation. Send me an email. I'd love to have a conversation and hear your ideas. But I see three distinct evolutions that are causing a need for new and modern control architectures. I'd call these three transformative trends, and they seem to be reshaping industrial automation. And this isn't just Weidmuller who's seeing this. There's a lot of really cool companies that'll be presenting, and you're going to see a lot of these echoes as well. The first one is IT-OT convergence. You may be familiar with this. This may be a new topic for you. The story of IT-OT convergence is really a what did we come from and where are we going? A simple way to think about this is we are coming from the isolated and air-gapped factory floor where your control systems are disconnected from anything. They can't send data in or out. Your IT systems and your databases are completely separate from that, and they're not talking. But with just realization of the power of data, the power of automation, the power of communication, we're seeing what we call this convergence, where these systems not only connect to each other, but different pieces of them start to live in the other. So you start to see databases on your plant floor, and you start to see control systems in the cloud. CODESYS Automation Server is a testament to this, of how CODESYS is embracing that. The second is edge intelligence. As processors become more powerful, as technology advances, as we start to see even AI becoming lighter weight, as well as intersecting with more powerful processors, you start to see at the edge, we are pushing for more and more capabilities to be hosted. In some ways, this gives you faster response time. It gives you better control of your systems. It's easier for vision, predictive maintenance, real-time process automation. But all of this demands being more capable to deploy, manage, and maintain more advanced technology, which would usually be hosted in a cloud or in a server farm at the edge, closer to your controls. And the third is platform independence. CODESYS is rocking this world right now, where we see that having a particular platform that you have to be locked into, that you have to build your IP and your technology stack on with very limited capability for migrating to another solution is very limiting. And you start to see companies that have engaged in newer PLC, newer controls technology, who are at the end of this cycle where they've built their products, they've built their technologies, and they're finding themselves locked in. And this is starting to be a frustration. I think CODESYS is an excellent solution for tackling all of this, but some quick statistics for you. We are starting to see a persistent growth in vendor lock-in inflation. And so there's a couple different research groups. Vertus is one of them that tracks globally how the average software subscription prices are increasing year to year. In the last 2 years, we've gone from a monthly growth of 10% in prices to 15%, and that can be compared against 3% consumer inflation average here in the US. So the idea behind that is platforms that lock you in and then raises subscription prices are going out of vogue. The second is that edge computing is taking off. This is awesome news for all of us here, all of the companies providing edge technologies, but it is a rapidly growing environment. And then the third is you're starting to see this phenomenon that as your control systems become more powerful, as your capabilities become more powerful, you're able to combine different systems that would have been standalone into fewer and fewer pieces of equipment. And so whether this is adding routing capabilities or IoT capabilities or database capabilities. You're starting to see this phenomenon that as platforms become more powerful and as independence is embraced, so you can combine technologies, you're able to consolidate the number of hardware platforms that you have to manage. So CODESYS being compatible with so many different hardware platforms, where you can pick what's the best hardware for my capability, who's the best vendor for my needs, is at the head of this innovation as we seek to move forward into embracing platform independence. The second point I want to make is that there seems to be a bit of an architectural shift that happens as you move from proprietary to open. And so I'm not going to make a claim that the traditional PLC system is going to go away. I think there's always going to be a place and needs for purpose-built PLCs uh, limited to the scope of their specific application, not necessarily connected to things. And I think CODESYS is going to continue to be a competitor in the traditional PLC system. There's a historic trend of vendor locking here, single purpose hardware, migrations that are difficult if you want to move from one platform to another, as well as limited integration options, limited ways that you can communicate, maybe expensive add-on licenses just to turn on something like OPC UA. For the traditional PLC system, I think CODESYS is winning that game. As traditional PLCs will continue to be needed, I think CODESYS is an excellent solution that avoids a lot of these pitfalls. But there's an open platform architecture, which I think is the future of industrial automation platforms. And this is an important and powerful shift in the automation world. This does things like demands portability for your control logic across vendors. Uh, I'd say CODESYS fulfills this as you're able to see so many different hardware platforms that you can very quickly and easy take a CODESYS application that works on one and transition it over to others. You need scalability, extensibility, and flexibility. You need to be able to take your application and deploy it to many different devices, extend that as you need, and the ability not just to deploy it, but to maintain it and to change it as you need. CODESYS has an automation server, which is, if you haven't used it, it's an excellent platform that enables you to manage a whole fleet of deployed devices and gives you pretty sharp ways to be able to manage the applications on those. It enables higher levels of integration. This is a point that I'm going to touch on later, but a big piece of this is CODESYS doesn't have to be used standalone because it enables integration with additional pieces. There's other pieces of technology that are maybe outside the scope of CODESYS, things like AI analysis, things like database management, different pieces of the technology that you can integrate really, really well, but you can still maintain your real-time guarantees. As we move to conversation, that sounds more like it belongs in a data a server farm. You have to remember that under the hood, these are controls applications. You need reliability, you need determinism, you need real time. You need to know that that conveyor belt's going to keep on moving. It's not going to start stuttering, no matter what's going on inside of my control systems. I think container-based edge applications is a critical piece of this. The ability to take any piece of software, whether it's custom software that you developed yourself or third-party applications that are available via containerization, and deploy and run those at the edge very easily. Containerization is the engine that's powering a lot of this right now. And getting a lot of these capabilities into one platform. So historically, a lot of this has been doable, but it's required multiple different platforms, multiple different pieces of equipment, server racks to be able to handle this type of capability. As we move forward and we're looking at what do modern architectures look like and what's required to fulfill that, consolidating these into fewer number of platforms that are as accessible as possible is critical. And so where does that lead us to? I'm going to do my best not to highlight our product, our operating system, UOS here at Weidmuller, because there's a lot of competitors who are seeing this trend, who are embracing it and moving in that direction. And that's awesome. We're really excited to see that. I believe Opto22 is presenting this week. And so you can call me out if I get this wrong, but as of their firmware 4.0, they released containerization support, and now they're becoming a powerful platform where you can deploy containers as well. There's a lot of technology manufacturers who are doing this, which is awesome. For our solution, I would say what CODESYS delivers is your hardware agnostic IEC 61131.3 runtime. It's proven in millions of installations. It's a powerful platform, runs on many different types of devices, and so you can decide what hardware platform is good for you. And it supports all the field bus protocols. So it's pretty much has universal compatibility. I listed a few of them here. What an open platform, an open, flexible, independent hardware edge platform brings to the table is the ability to host applications like CODESYS on the edge with integrated container runtime to also support non-PLC applications, and to do that in a way that respects the requirements of determinism and edge operations and computation. And so maintaining that the resources available on the device to run CODESYS, to run it stably, to run it consistently, that you're able to do that while you're also able to host third-party applications. Maybe that's a database that you downloaded, maybe that's some custom software that you wrote. This I would argue is the architecture of the future. And a key insight here is that these are complementary architectures. And so CODESYS as the engine that runs your industrial automation equipment, and then a powerful hardened edge platform to host that, as well as to host additional pieces of technology and applications. I want to touch just one level deeper of what does this look like architecturally. And so this might be similar to diagrams you've seen of application stacks for containerization or virtualization. But I think this looks like a four-tier architecture. And at the top tier, you have your management layer. You have cloud services that enable managing and hosting your technology, especially critical for fleet management as this technology is distributed. And then you have your platform layer. I'm going to jump down to bullet 3, where you have your hardware, which is running. You have your management operating system running on that. And then you have the control layer. And this is where CODESYS is running. CODESYS is tied pretty close to your hardware, maybe so it can use your onboard I/O modules, your digital and your analog inputs and outputs, as well as tie into hardware peripherals like network ports. And CODESYS is able to take advantage, or rather, you're able to take advantage of the entire suite of CODESYS features that are available for your platform, including things like dropping in the edge gateway so you can tie it to your automation server. And all of this powers your connectivity all the way from the top layer down to the field layer, where you have your field bus protocols, which is where the magic happens as you're interfacing with your systems and your equipment, and you're able to control it together with this stack. A critical piece for this whole architecture to work is integration. And I just want to touch back to this for a second, because this is one of the super powerful capabilities of CODESYS, is just that it has such broad and open integration. So built-in OPC UA support, which just runs when you turn it on. You're very easily able to drop in a symbol configurator and be publishing OPC UA variables or receiving OPC UA variables using your data source manager to bind multiple CODESYS controllers to the same OPC UA server. It's super powerful in that. It's easy to get going with MQTT in CODESYS. There's standard support for all the field buses that there are. And then with an open platform, such as UOS or an open operating system, You also start to see more and more in the way of REST APIs or easy ways that you can interface with controls and configuration of the hardware or access to I/O slices. And so all of this leads to demonstrating how having open standards driving your integration enables an application like CODESYS to become so much more powerful in the context of modern and future-ready controls architectures. I'd say that we've covered a lot of this, but if I had to summarize that into three core architectural principles, I would say that you have the CODESYS domain, which is your deterministic control, industrial communication protocols, real-time tasks, safety logic. I'd extend that into a lot of the other CODESYS features like automation server for cloud control, so tying up the stack to those. And then I'd say that there's the operating system domain for application lifecycle management, container orchestration, managing and hosting the security requirements and updates for the platform itself. Whatever CODESYS is running on, it has to be secured. Using non-real-time services, and so facilitating things like custom software or additional applications that aren't real-time in nature, and then resource allocation to make sure that everything that's running on your edge architecture is able to operate reliably and is not going to deteriorate each other. And then you have your integration layer, which we just discussed. So that's all your communication protocols communicating back and forth. What this does is it makes it very easy, and I like the word accessible, to do really advanced things on the edge. And so I have a little application story I'm going to go through quick. The goal of this is not to do a big, crazy application. The goal is to show just how accessible a lot of advanced technologies are coming nowadays. And so this is an AI application, which is why I let the AI make the image for you there, which is nice and creative. This is what it comes up with for vision control. If you haven't used AI image generation, it's a trip. It's a lot of fun. So try that out maybe. The goal of this was find a way to very quickly, very easily deploy AI video analysis right on the edge on a controller right next to CODESYS. And then take the feed from that AI analysis, feed that into CODESYS, and then use that downstream as CODESYS does all of its controls operations. And so this is about 8 hours of work. It's not a lot of work. This technology is just becoming more and more accessible these days. And so this is a proof of concept for a customer who had a product idea and wanted to ask us about it. And so the goal was take a video feed, just a little PoE camera. It's one Ethernet port, and it receives power over that. Take the feed from that, look at it, use that to take an AI engine to analyze that video feed. And you can really go anywhere when you start talking about what type of feed can I analyze, what can I do with that. It's very powerful and capable, so your imagination is the limit. In this case, as a proof of concept, we just took finger gestures, number of fingers that you're holding up, and used the AI to figure out, hey, how many fingers am I holding up? I'm going to feed that over to CODESYS, and then CODESYS can take that and can operate with it. The way that we did that was we took one of our controllers. We have UOS running on that, of course, and then we deployed CODESYS on it, and then we just wrote a little Python script. In all fairness, a lot of this was the code was AI generated. This was pretty simple to do these days. Containerized it and dropped it onto the controller running next to CODESYS. And the architecture looks like I kind of covered this a moment ago, but you have your hardware layer where your equipment's running. You have your industrial PoE camera, a couple standard I/O modules. Then you have a little bit of custom AI software that you wrote. We just used Python, a few very accessible Python libraries, stitched together a little application to take in the feed. and then just publish that to OPC-UA. Because CODESYS makes it so easy to turn on an OPC-UA server, create your variables, be publishing right to that, it was trivial to write the Python code to, hey, just take the number of fingers you came up with, push that over to CODESYS, let it run from there. And then CODESYS takes that and it's able to run with it. A little feed. This is what it looks like. At the end of the day, you're holding up a number of fingers. It's showing this to you. This is, if there's any AI experts in the audience, you'll know that this is trivial. This looks like about 8 hours of work. But to go from this to something professional, something that's tested consistently and reliable, is a pretty straightforward path. And so this is how accessible the technology is these days. With just a little bit of time, a modern platform and architecture, you can create an application that runs. Maybe it just takes in a little bit of configuration for your camera feed and for, hey, here's my OPC-UA server and CODESYS and my variables. And now you have that inside of CODESYS. So CODESYS takes that and you're able to run with that, take in the entire suite of CODESYS capabilities and power your plant right alongside this type of technology on the edge on a single hardware platform. And so the flow of this, again, pretty simple. Image acquisition, you take in your video, you do your AI inference using some sort of engine. And as a note, a lot of forward-thinking platforms are utilizing extensions for AI acceleration. This is often in the form of like M.2 extensions where you can add little graphics accelerations. That just shows how a lot of this technology is pushing closer to the edge, and having open interfaces on a platform like CODESYS that's able to marry with that very easily is so powerful to get your PLC response. Key benefits of a platform like this, first off, is modularity. For anyone who's managed a complex industrial environment where you have multiple controllers and multiple PLCs, common question is, hey, if I need to change this thing, how many things do I need to change? This type of modern architecture makes that easy because you can have your CODESYS application, which has things like strong controls on versioning, on online versus offline updates, where you can retain that strong control over your PLC application lifecycle. And then you can have kind of a separation of concerns for your third-party applications running alongside that. And so they don't break each other, they're more resilient, and they're more independent. You're able to maintain excellent performance capabilities, and with the incoming of new hardware acceleration modules closer to the edge, your performance is just going to keep going up. And using capabilities like CODESYS Automation Server, these types of technologies that allow you to scale up, it makes it easier and easier to manage a wide fleet of controllers and technologies. And so I'm about at the end of my time here. And so one last note in closing, which is, pardon me, there's a wide variety of applications that we're seeing rolling up where combining these types of technologies, these types of modern architectures, being able to add more and more pieces close to the edge, interfacing with them really well from CODESYS, and managing your infrastructure like this is powerful. It's everything from quality inspection to part identification to process monitoring. So many different pieces of technology where a lot of data exists. And this convergence of IT and OT, as we can get more and more access to more and more data, you're able to do really cool stuff with this. And we think that CODESYS is oriented to be the excellent platform to carry that modern industrial automation architecture into the future. So that is it for me. Thank you for your attention. Chris, thank you for your time. If you have any questions, feel free to reach out to me or to Weidmuller. We appreciate it.